Welcome students. This is Ravi Shankar. See, in our last class we have studied about the example number 1.12, and now let us start with the next problem, an important problem which may be asked for an 5-mark question. Go with the problem now. Consider a point charge plus q placed at the origin and another point charge minus 2q placed at a distance of 9 meter from the charge plus q. Determine the point between the two charges at which the electrical potential is 0. First of all, draw a diagram for this concept or for the given problem. Say, consider a point charge plus q placed at the origin. So I am considering a point as the origin, and at this point origin I am having a charge considered to be what? And I am having a charge taken to be plus q. Now, and another point charge minus 2q placed at a distance of 9 meter. So from this charge at a distance of 9 meter, I am considering another point where you are having another charge minus 2q. What it is asked, determine a point between the two charges at which the electrical potential is 0. So I have to consider a point in between the two charges where the potential is 0. So what I am doing is, I am taking a point in between, I am taking a point P in between what? In between the two charges. And I am assuming that at this point the potential V is equal to 0. And I am assuming that the potential at this point is equal to 0. See, I am taking this point P is at a distance of x from the origin. Then what is this remaining distance? This remaining distance will be equal to 9 minus x. So I have to consider what is x. At what point in between the two charges the potential is 0. Either I can represent the point from plus q or from minus 2q. How I can able to consider? See, first of all, I am taking like this. Let us take or let us consider. Okay, let us consider a point P in between the two charges, in between the two charges at a distance x, at a distance x from plus q at origin, at which the potential is 0. At which the potential is 0. I think you are clear about this. So I am considering a point P at a distance of x from this charge plus q which is kept at the origin, and at this point the potential is 0. See, at this point the potential is 0 means how I can explain it. See, I am drawing the diagram again and I will be explaining it. You see, you are having the charge here at O origin, you are having the charge plus q, and here you are having the charge minus 2q. In between I have taken a point P which is at a distance x, so that this distance I am considering it as 9 minus x, since the total distance is considered to be 9 meter. This point is experiencing two potentials. One I am considering it as due to this plus q, and another one due to this minus 2q. I am taking the potential at this point P due to plus q as V1, and I am considering the potential at point P due to minus 2q as V2. Sum of these two potentials at this point is 0. Isn't it? See, at this point, V is equal to V1 plus V2, which should be equal to what? Which should be equal to 0. So using this, let us calculate what is the value of or what is the distance from O. So for that, I am writing the concepts. Potential V1 at P due to plus Q. So what is the potential at P due to Q plus Q1? It is 1 divided by 4 pi epsilon 0 into Q divided by this distance, that is x. Similarly, let us consider the second one. Potential, I am taking that potential as V2 at point P due to minus 2q. Let us take that as V2, which is equal to 1 divided by 4 pi epsilon 0 minus of 2q divided by, what is that distance? That distance I can consider it as what? That distance I can consider it as 9 minus x. See, in the diagram itself, I have noted out clearly that total potential at P is equal to 0. Total potential at point P is V1 plus V2. So we can write, since the potential is 0, so I am writing, since at P V is equal to 0, we can write, that is sum of the potentials at P. Sum of the potentials at P is equal to 0. So how I can write? The net potential V is equal to, the net potential V is equal to V1 plus V2 equal to 0. What is V1? 1 divided by 4 pi epsilon 0 into Q divided by X. Here plus, here you are having minus, so minus of 1 divided by 4 pi epsilon 0 2q divided by 9 minus x is equal to 0. Now you have to calculate the value of x. At what distance from the origin that electrical potential is 0. How to calculate? Simplify this. How to simplify? See, 1 divided by 4 pi epsilon 0 into q divided by x is equal to, take this to the other side, 1 divided by 4 pi epsilon 0 into 2q divided by 9 minus x. Simplify this 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, and this q will get cancelled. What is the remaining thing? The remaining I can consider it as 1 divided by x is equal to 2 divided by 9 minus x. Make a cross multiplication and simplify. So you will be able to get it out as 2x is equal to 9 minus x. Take that x from right side to the left side, you will be able to get 2x plus x, you will be getting 3x, which is equal to 9, or x is equal to 3 meters. So this is the answer, the distance of point P from O. So we can say that, therefore, okay, I can write, therefore, at a distance of 3 meter, at a distance of 3 meter from the origin, 3 meter from the origin, the electric potential is 0. You can also say it in another way. See, if it is at a distance of 3 meters from origin, means it is at a distance of 6 meters from the other charge minus 2q. Because we can say 9 minus x, isn't it? 9 minus x is the other distance. 9 minus x, what is 9 minus x? It is 9 minus x, the value is 3, so it is 6 meters. This we are calling it out as the problem number 1.13. I think you are very clear about this, and an important problem for 5-mark question. You can expect this for compulsory problem also. Still we are having 2 or 3 more problems that we shall do it in our next class. Thank you.